Hey everybody. So this is going to be a quick video on just kind of like the bare bones basics of logarithms. So what the definition is, how to apply it to a couple of different problems, and then I have a third problem too that I'll bring up that is kind of maybe the most useful problem that you'll come across because it's more practical. So the definition of logarithms is sort of stated right here, and this is just a definition. You just have to take it at its face value. There's no like deriving it. So the definition says that log base b of x equals y if and only if b to the y equals x. So it's kind of a lot to remember. The way that I remember it is that from this first form, log base b of x equals y, this is equivalent to saying that b base raised to the yth power equals x. And yeah, I make these little arrows. I mean, I've been doing math for however long, and I still make these little arrows. It feels kind of childish, but it helps me to remember because for whatever reason, it's just like there's a lot of moving parts involved with this. And then going the other direction, it's, you know, obviously the same thing. Whatever the number is that is being raised to an exponent, that's the base. So this would be log base b. To rewrite this in terms of logarithms, log base b of x equals y. So log base b, and then the little arrow would be on the other side of the equal sign is the exponent y equals x. So these are equivalent statements. You can interchange these, rewrite it however it works for you. To help solve a problem. So an example problem is something like this. 10 to the x equals 31. 31 is not a power of 10, so it's not going to be a nice clean number. Maybe if you are like Rain Man calculator level, maybe you know what x needs to be. I sure don't, most of us don't, and that's what logarithms are used for. So, to solve something like this, 10 to the x equals 31, first we're going to rewrite it in terms of its logarithmic equivalent. So the base is 10, so it's going to be, this is the same as log base 10 of something equals something. So 10 raised to whatever, so over here on the right hand side of the equal sign is the x, right? This is like the bottom arrow that I'm using right here. 10 raised to the xth power equals 31. So 10 to the x equals 31 is equivalent to log base 10 of 31 equals x, and x is what we want. So again, this isn't something that you can really do by hand or off the top of your head, so we need to do log of 31. And by the way, on your calculator, most calculators will have two different log buttons. One is the log, and then the other one is natural log. This one that is just written as log means log base 10. So anytime you see log just written and the base isn't specified, it's implied that the base is 10. You can have other bases. You can have any base at all. The other base that is logarithmic base that appears on most calculators is the natural log, which is log base e. So in any case, if we want to solve something like this, we need to have it as an expression of either log base 10 or log base e. So in this case, we have that, log base 10 of 31. So here it is, log of 31 is 1.49, whatever this is. So it's about 1.4914. How can we be sure of this? Well, what this is saying is that 10 raised to this number should be 31. So let's check. 10 raised to that number comes out to exactly 31. So yeah, x is 1.4914, or log base 10 of 31 is 1.4914. What if we're going the other way? What if we're first given something that is logarithmic, but it's not a base 10? Well, we have two options. One option is we can rewrite it in terms of its exponential expression, because it might be a nice, clean, somewhat easy number for us to calculate out. The other solution, the other method, is using something called the change of base formula. So for this one in particular, we can do this just by rewriting it as in its exponential form, which you might want to do first, just because it might be a little bit easier. So log base 3 of 27 is the same as, and here's how I do this, by the way. I'll give it a name. I'll say that log base 3 of 27 is going to be, you can call it whatever you want, we use x a lot. So I'll say, all right, log base 3 of 27 is going to be some number, x. Well, this is equivalent to saying that 3 raised to the xth power equals 27. And maybe you know off the top of your head what x must be. 3 to the x equals 27. If not, that's okay. Turns out that x is 3. 3 cubed is 27. 3 squared is 9. 9 times 3 again is 27. So sometimes rewriting it in the exponential form makes things easier just because it'll be like a convenient power. If this was not, if 27, or what was on the right hand side here, wasn't a power of 3, we would have to use the change of base formula though. So, the change of base formula, I'll just write it out here first, and then we will use it in an example. So the change of base formula says that log base b of m is equal to log base n of m divided by log base n of b. So the idea, the whole reason it's called the change of base formula, is we can take some logarithmic expression that has whatever base, and we can rewrite it into a ratio of logs of whatever base we want. So we can choose this base n right here. So as an example, let's look at, let's try to figure out what is log base 7 of 119. So again, first thing that you might want to do, just to make sure, is rewrite this in its exponential form, because maybe we're lucky and maybe it's not too difficult to solve. So I'll give it a name. I'll say log base 7 of 119 is x, so this is equivalent to saying that 7 raised to the xth power equals 119. And I'll just tell you right now, this is 119 is not a power of 7. So it's going to be something nasty. So, but this still is going to be kind of helpful for us, just to make sure that, like, you know, we're on the right track. Because then when we get to the very end, then we can double check our answer with whatever we get for x. All right. So if that doesn't work out, we need to use the change of base formula. And again, remember, the reason that we need to use the change of base formula is that most calculators, they only have buttons for log base 10 and log base e. I don't have a button for log base 7, so I can't just plug this into my calculator and figure out what is log base 7 of 119. I need to rewrite this so that it's either a ratio of log base 10 or log base e. So we've got some variables here. If you just look at this change of base formula, there's b, there's m, and then there's n. So we have, I was counting off of the camera. There are three different variables that we need to keep track of. So it probably will be helpful for us to write out what these three variables are. So, and two of them are decided for us. B is 7. That's the original base that we're looking at. So B is 7. M is whatever is inside the argument. That's what we call, like, whatever is inside the parentheses. It's whatever the argument is of the original log. So log base 7 of 119. M is 119. So what is n? Well, we get to choose. It's either 10 or it's e. Why those? Because the only buttons that I have on my calculator are log base 10 or log base e. And it doesn't matter. You can choose whichever one you want. You get the same answer either way. I'll use 10, just since that's what we've been using already. So just plugging everything into the change of base formula, log base 7 of 119 is log base n, so n is 10, log base 10 of 119 divided by log base 10 of 7. And now we can plug that into the calculator. So we're just looking at what is log of 119 divided by log of 7. It's about 2.456. How can we double check this? Well, this whole original thing is saying is that 7 raised to this number should be 119. let's check. 7 raised to the answer comes out to exactly 119. So we're good to go. So just two like quick little notes I'll make here. Log of x. If the base is not specified, it's implied that it's log base 10. If any other, like if no base is specified, it always means log base 10. Otherwise, the base needs to be specified, except if it's log base e. That gets a shorthand. So log base e of x, we call that the natural log, and it's written as ln of x. And yeah, that is ln. I know on the calculator, a lot of times people read that as in. No, that's an L. ln, natural log. So natural log is literally just log base e. Everything else, like the definitions, are all the same. So don't get hung up on this notation, the ln. It just means log base e. All right, so that's that. Let me know if you have any questions.